recording? Mm-hmm. Okay, so as I said, guys, this is what we call a homologous series, where you have a very similar chemical structure. The only thing that differs is the number of carbons, but they all have single bonds, and they're all a continuous chain, sequence. All right. So you need to know these prefixes. So for organic chemistry, when we're looking at the main molecule, which I call the parent molecule, meth is 1, eth is 2, prop is 3, but means 4, pent is 5, hex is 6, hept is 7, oct is 8, non is 9, and dec is 10. So you don't really need to know, prefixes above 10 for Chem 30. If you're going to progress on to higher levels of chemistry, you'll know naming prefixes for, for the first 30, 40 molecules in a homologous series. All right? So meth or eth or prop or but, they indicate the number of carbons present in the parent chain, and the suffix will indicate the type of molecule present, right? So 1 carbon in an ANE molecule. So ANE is an alkane. So there's 1 carbon in a single bond carbon unit. That's what that means. All right. So we'll do some more examples as this progresses. I'm only going to do alkanes today, though. So let me give you a couple examples, and we're going to start real simple. So example says draw. So I gave you this already in the previous lecture. Draw a structural, condensed structural, line structural. So this would be complete structural. Condensed structural and line structural diagram for the following molecules. One is methane. All right, so let's do this one first. Methane is CH4. It has 1 carbon and 4 hydrogens. That's about as simple as it gets, right? So that's your complete structural. A condensed structural diagram for this one actually looks like this. There's no double bonds, right? Because there's only 1 carbon. And a line structural diagram for methane is kind of weird, all right? Because there's only 1 carbon, it actually looks like that. Okay? That's a bit of a special case. So you can use this, or none is alright as well. Now, if we had a Lewis dot diagram, so you have to be able to do that as well. Right, a Lewis dot, now this is straight from Chem 20. A Lewis dot diagram looks like that, right? Now you also need to be able to do molecular models. So I'm just going to pull the camera over this way. Right, so the model kit, I'm not going to do model kits for all of these, but if you guys were in class, this is what I would be having you do. I would put the line structural diagram on the board and the condensed and the complete structural diagram, and then I would actually have you build the models. All right, so you'd be doing a bit more active learning. So this is the molecular model for methane. All right, now you're going to have a bell ringer test. So an oral exam where you have stations and you move between the different stations. I'm going to record a bell ringer, and I'm going to give you a bunch of these molecular models, and you are going to have to identify the molecule. So as a reminder from the last lecture, black for model kits equals carbon. White is generally hydrogen. double bond, you can see that there's a double bond to O. Blue double bonds are oxygens, okay? And then you have other things that are relatively common, like nitrogen. Nitrogen is red, okay? And you'll often see things like phosphorus. Phosphorus is purple. But before I give you a test, I will give you a legend that will tell you what these different things are. Okay? So that's the model kit there. Let's keep going here. I'm going to just cover the screen up for a second. So propane, so prop is 3, okay? So the table with all the prefixes is on page 366 in your textbook. So where meth, eth, prop, bute, pent, and all that is. You have to memorize those first 10 prefixes. Those are all table 3, page 366. So have that out when you're doing your work. Propane is C3H8. So if I were to make a complete structural diagram for that, it looks like this. Okay, C3 and then 8 hydrogens. A condensed structural diagram looks like this. CH3. There's 1, 2 hydrogens attached to this one, and then there's 3 attached to this one. So that's a condensed structural diagram. I'm not going to draw the Lewis dot because you're not going to use it that much. But the line structural diagram, right, there's 1, 2, 3 carbons. So as a reminder from the previous lecture, every time there's a break or an end in the line, that's where a carbon is. Okay, so this indicates the line structural. I might use this in class too. This is a skeleton diagram where I just don't put the hydrogens. Okay, so this is a skeleton structural diagram, which you don't see much, but it's useful for like classroom examples. So just be aware that that could be something you see as well. Octane, let's do this one. So this one, so oct is 8. And again, the A and E means 1 carbon, okay? So oct is 8. So we have 1, 2, 3, 4. And one thing I'm going to do is this, is I'm just going to, so there's 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to jumble it up a little bit, because one thing you should understand is that when we look at alkanes, alkenes, and alkynes, if we look at this in nature, unless it was altered, it would probably just be a straight chain. But it doesn't necessarily have to be. All right? The longest chain, the longest continuous chain is what the molecule is. All right? But it doesn't necessarily have to be the longest straight chain. It's just the longest chain of consistent carbons. So when we talk about branched alkanes, that's going to be really important. So don't get stuck in your head that it needs to be a straight line to be like the parent base of a molecule. All right? So all these dashes is where hydrogens would be. So then that's my complete structural diagram, right? So H, H, H. H is all here. They're all saturated hydrocarbons, so the carbon needs to have 4 molecules attached to it, right? So there's 1, 2, 3, 4 molecules attached to this carbon, and there's 4 molecules attached to all the other ones. So that's octane. The condensed structural diagram looks like this. So I'm going to take this CH3, CH2, 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 it's 5, CH2, CH2, CH3. So I straightened it out just to make it a bit more clear. All right, that's my condensed structural diagram. My line structural diagram looks like this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 carbons here. All right? So These are called straight chain alkanes because there's no branches off of them. This is about as simple as it gets. Okay? So, we're not going to spend a ton of time on straight chain alkanes because of their simplicity. So this is the first level of complexity when we talk about organic chemistry. So these are branched alkanes. So it's a long chain alkane with smaller chain carbons attached to it. All right? So I'm gonna put this on the board and we're gonna talk about what it is, and then I'm gonna do a bunch of examples and I'm gonna teach you how to name these. So this is CH3, CH, CH3, CH3. Now what I need to do before I name this is I need to recognize what the longest chain is. So the longest chain is 1, 2, 3 carbons, but it could be this as well, 1, 2, 3 carbons. It doesn't really matter which direction I go. So I need to identify the longest chain. The longest chain is 1, 2, 3 carbons, so it's propane. And we can have multiple different types of branches off of this. Now, remember that 1 is meth, 2 is eth, and 3 is pro. Okay? So, when we name the branches, we use the same prefixes. Now, branches are indicated with YL at the end. Okay? YL. So, branches are alkyl groups. So that's how we differentiate the branch from the parent chain in large organic molecules. So this is a single carbon, and it is a branch. So it is a methyl group. So the way we would name this is methylpropane. All right? Now, in order to name this properly, I would actually name this 2-methylpropane. Because it's on carbon 2. Now the thing is with the propane, there's only one place for there to be a branch. It has to be on carbon 2. So I don't really need to add that. Because if let's say I did this, and then I theoretically put a branch here. All right? Same number of carbons, same number of hydrogens. This is an isomer of that. Same chemical formula, different chemical structure. Now, if I look at the longest parent chain now, though, it's 1, 2, 3. There's actually 4 continuous carbons. So I don't have alkyl groups on terminal carbons. They're just part of the main branch. So this is no longer propane, that's butane. Okay? So there's only one place to have branches on a propane molecule. So that would be methylpropane. Okay? So, you have instructions in the notes. For naming branched alkanes. So step 1, I already kind of pointed this out. It says find the longest continuous chain of carbon atoms, circle this chain, and label it. Name the longest chain as if it was a continuous chain alkane. Find the extra branches and circle them. Each branch is an alkyl group, and it'll have numbered prefixes. So methyl, ethyl, or propyl. Number the carbons on the main branch, starting with the end carbons closest to the branch chain. So the carbon number 1 is the one that's closest to where the branches start. All right, so carbon number 1 is where the interesting stuff starts. All right, or the closest terminal carbon to where the interesting stuff starts. So I'll point that out as we go. Assign each branch the appropriate number from the main carbon chain. Use the appropriate prefixes. Indicate how many branch chains there are with them. This goes in front of the continuous chain carbon's name, and put it together. Okay? So, let's do an example. So let's say this is 2-methyl-pentane. 2-methyl-pentane. Okay? Your parent chain is 5 carbons. And it's single bond because it's A and E. So CC, so 5 Cs. And then you have a methyl group, which is one alkyl group with 1 carbon. And it's on carbon number 2. So I'm going to number this 1, 2, 3, 4, 5. Okay? So fill this in. There's 1, 2, 3 bonds to this carbon already, so this is only CH. So there's only one more bonding spot. There's only 2 bonds attached to this carbon. So that's CH2, CH2, CH3. All right. Now my chemical formula for this is 1, 2, 3, 4, 5, 6 hydrogens. It's going to be C6H14. Now if I look at this molecule, 1, 2, 3, 4, 5, 6. Okay, this is also C6H14. This is hexane though, right? These are called structural isomers. So these are structural isomers where they have the same chemical formula but a different chemical structure. Same formula, different structure. Okay? So they'll have different properties as a result. Let me give you another one that's very similar. So you have to be able to go from the formula to make the molecule, but you also have to go from the molecule to naming it as well. So this is what, let me draw this one out. Okay. So we need to identify the longest chain. So we could go 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. I could go 1, 2, 3, 1, 2, 3, 4 here. This is what's called a chiral molecule. Okay? So they're mirror images of each other. Alright, so if I were to split this right down the middle, these are reflective images of each other. Alright, so that's called chirality. That's really important for molecular stability. I'm not going to get into that a ton right now, but we'll talk about it more when we get into benzene. All right, so the big reason why I said that is because it doesn't really matter which way I start from. All right, I'm going to get the same result. So let's say this is the longest chain. And I'm going to number this 1, 2, 3, 4. Now you should use different colored markers or pencil crayons when you do organic chemistry. Because what I have is 2 side branches here. Alright? So I'm going to name this. This is also C6H14, by the way. Right? There's 6 carbons and 14 hydrogens. Okay? So this is a structural isomer of these guys. So I'm going to name the parent molecule first. So name the parent molecule. It's 4 carbons. It's single bonded. The parent molecule is butane. All right? Then I have 2 methyl groups. So these are 2 alkyl groups, and they have 1 carbon. So the way I name this is this. So I have to indicate where they are in the molecule. So I have a methyl group on carbon 2, and I have a methyl group on carbon 3. That's 2, 3, and I also have to indicate how many there are of them. So this is 2, 3 dimethyl butane. So I could use di, tri, tetra, penta, okay? So this is 2, 3 dimethyl butane. All right, so I have to indicate where the extra alkyl groups are, and I need to indicate how many of them there are, and I need to indicate what they are. So everything has every little prefix and suffix has a meaning that matters in organic chemistry. Okay, let's keep going with some of these branched alkane examples. So, a sample problem says, write the IUPAC. So this is the name. This is the acronym that stands for the International Agency of Chemistry. So the IUPAC name corresponding. So this organization basically controls chemistry worldwide, corresponding to the following condensed. So IUPAC stands for the International Union of Physical and Analytical Chemists. That could be a bonus question, by the way. So they basically set the rules and standards for chemistry worldwide. Okay, so write the IUPAC name corresponding to the following condensed structural formula for a component of gasoline. I'm going to draw the line structural diagram for this. Okay, so let's name this. So there is side branches. So remember, every end is a carbon. So there's a carbon here and a carbon here, carbon at each break in the line. So I'm gonna try to figure out what's the longest branches. So this is 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So 6 is my longest branch. And I number carbon number 1 from this side because it's closest to where the side branches start. So this is not carbon number 1 because it's further away from where the interesting stuff happens. Okay? So this is carbon 1, 2, 3, 4, 5, 6. This is a side branch, and then this is a side branch. Okay? So I'm going to name my parent chain first. So this is a single bond, and it's 6 carbons. So it's hexane. And this is 2 carbons. So this is 1, 2, and this is 1. So this is an ethyl group. And this is a methyl group, right? Eth is 2, YL means side branch. So I named this in alphabetical order. So this is 3 ethyl, 2 methyl hexane. So I always name my side branches in alphabetical order first. Now, if this was, let's say this was 3 ethyl, 2 3-dimethyl. All right, so let's say there was 2 methyl groups. All right, this would indicate 2 methyls, but I would still write it as 3-ethyl, 2,3-dimethyl. I wouldn't put the dimethyl in front of that. I wouldn't do that because because the di just indicates how many methyl groups there are. This doesn't indicate the type of side branch. So it doesn't count when we look at alphabetical naming. So it stays 3-ethyl, 2,3-dimethyl. Even though D comes before E in the alphabet, we don't use that when we're naming the order. Okay? So here's the problem with orgo is the I really like organic chemistry. I think it's like my favorite part of chemistry, but the rules are nitpicky. All right? So the prefixes that indicate the number of the alkyl groups, they don't count for putting the alkyl groups in alphabetical order. All right? So, so that's a gasoline additive, right? A lot of our additives inside gasolines are branched alkenes because they increase the they increase the ignition point and they increase the stability of the molecules. Okay. So let's. This is going to say draw a line structural formula for the following. A is CH3, CH2. Okay, so line structural formula, so there's 1, 2, 3, 4, 5 molecules as the parent molecule. And then I have a methyl group, so it goes there. All right, so this is 2-methylpentane. Here's one that's a bit more complex. Okay, so 1, 2, 3, 4, 5, 6. Now that's not a side branch, right? Now so there is a side branch. This is my longest continuous chain. Now the trick is which way do we name from? So this is 1, 2, 3, 4, and this is 1, 2. So that's my carbon 1, because it's closer to where the nearest side branch starts. So my parent molecule is hexane. So I'm going to name that first, and then I'm going to fill everything in after. Okay? And this is a side branch, and this is a side branch. So this is 1 carbon, and this is 1 carbon, and they're on carbon 2 and 3. So this is 2, 3, and there's 2 of them, so it's dimethyl hexane. Okay? Okay, so, homework. I'm going to do some examples here, but I want you to do this for homework. Name and draw all structural formulas for CH4, C2H6, C3H8, C4H10, C5H12, and C6H4. Now I've already kind of done this, but this is a homologous series, right? Because they all have the same properties, and they increase by the same amount each time. Okay, so do that on your own. But let's do a few more here. So examples. Let me give you this one. Okay. So this is a line structural diagram. Longest chain, let's figure it out. So 1, 2, 3, 1, 2, 3, 4, 5. This would be 5 as well. 1, 2, 3, 4, 5, 6. So this is my longest chain. So that's hexane. And each of these have one carbon. And so this is carbon 2 because it shows up first. These are on carbon 3 if I went this way. So this is 1, 2, 3, 4, 5, 6. So I name this as carbon number 1 because the nearest side branch is closest to that one. So I have 2, and then I have 2. So again, this is an easy thing to miss, but there's a methyl group here, and there's a methyl group here, and they're both on carbon 4. So this is actually 2, 4, 4, trimethylhexane. You would be wrong if you just said 2, 4. Okay, so if you said 2, 4 trimethylhexane, you would not be right. Okay? Because you need to give location for each methyl group. Okay, let's look at this one. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 again. So this is going to be 1, 2, 3, 4, 5 here. So this is again going to be hexane. And this is going to be my carbon 1 because this side branch is closest to this terminal carbon. So that is my parent chain. Okay, and then I have side branches here, here, and here. And that's 1, 2 carbons. That's 1 carbon, 1 carbon. All right, so I have an ethyl group. So this is 3-ethyl. And then this is on carbon 2 and carbon 4. That's 2, 4 dimethyl hexane. All right. I want to give you 2 more here of alkanes, and then we'll be done for this lecture for the day. Okay, so this, again, I'm going to use line structural diagrams most of the time because they're the simplest ones to put on the board. All right, so we have 1, 2, 3, 4, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. So this is actually my longest chain. 1, 2, 3, 4, 5, 6. So it's not always intuitive where the longest chain is. That is an easy one to miss if you're not careful. All right, so again, this one's hexane. And then I have a methyl group on carbon 2, and I have a methyl group on carbon 4. So that's 2, 4,